Okay, so yesterday, remember we left off talking about adding to the input, and one of the things that came up in one of my discussions with a student yesterday was, why is the graph moving, this graph moving left to right rather than up and down? And it's probably didn't do the best job at describing that, so let me make that really clear. Okay, when we're saying we're adding to the input, we're changing the input, it means that we're changing our x value. So, for instance, in this case right here, we're saying f of x plus 5. That means we're taking the input, and whatever it is, we're adding 5 to it. But no matter what, we're still going to get the same output of 3. So you got to think, okay, if the input, the original input of 2, that original input of 2 gives me an output of 3. So we know that 2 gives an output of 3. You need to say, what number can I add 5 to that would still give me a value of 2, so that my output is 3. So what number plus 5 is 2? Negative 3. That's how we get to that point. Okay? So we know that f of 2 gives us an output of 3. We know that. Okay, when our input is 2, we get an output of 3. So this is saying, well, if I'm adding 5, what number can I add 5 to get me back to 2? Okay, and that would be negative 3. That's why our graph, this point shifts that way, rather than going upward. Your output's not changing, your input is. Okay? Because negative 3 plus 5 still gives me that 2 there. We'll do a quick discussion. All right, so today we're going to talk about multiplying the output. Okay? Multiplying something by the output here. Okay, when we do that, remember output is that inside or outside? Outside, right? Out, meaning out, outside here. So if it happens on the outside, remember yesterday we discussed things that happen on the outside. Is that vertical or horizontal? It's vertical, okay? So if I'm adding to my note page, so you have your note page, and yesterday we had a big set of notes, so if we're adding to that today, our new section would be multiplying the output. Okay? And that's in the form of g of x equals a times f of x. All right, so really what we're dealing with is this value right here, the a term. So we're taking something and we're multiplying our function by that. All right, so if we had our regular input values, now remember our 2x minus 1, that's the same function we were dealing with yesterday. If we have all those different input values and we get outputs, it gives us this same line that we dealt with yesterday. So if we were to plug in values for x and do all the math, we'd end up with this line. Or if we use y equals mx plus b, we'd end up with that line. You recall yesterday when we had an input of 2, our output was 3. So we had the ordered pair 2, 3. Okay, well we're going to be multiplying the output. So which is going to change, the 2 or the 3? Which one's the input, which one's the output? Tell your neighbor that. Okay, which one's the input? 2. The output is 3. So which one's going to change? The 3 is going to change. Okay, so when we do, and this says 3 times f of x, you may have to make that a little darker. Didn't copy well. Okay? We're going to say a is 3 here. So we're going to put a 3 in for the a. This means that the output is transferred or transformed. It'll be 3 times as big as the original. It's being stretched away from the x-axis. So we're moving the output. So the output that was at 3 is moving up 3 times as much. In other words, this distance that was right here, this distance is a length of 3 originally. That length is going to change to 3 times that. So 3 times 3 is what? 9. So the new distance is going to be 9. You're moving away from the x-axis when you stretch it vertically. You're stretching it away from this axis. Okay, so we're now at 9. Okay, so the point that was at 2, 3 now is at 2, 9. Notice the input stayed, the output changed. We good there? That happens to every single point. Now, in equation form, what's actually happening is if I take, just like we did yesterday, let's give ourselves an example here. We know f of x is equal to 2x minus 1. And we know that we're doing 3 of f of x. That's what g of x equals. G of x is equal to 3 times f of x. Okay, so just like we did yesterday, to get this coordinate 2, 3, we did f of 2. We put 2 in for x, we solved it out, and that gave us 4 minus 1, or 3. So when x was 2, or is 2, y is 3 in our original. Now when we do this function, notice the f of x is right there. That means we take what f of x is equal to, and we replace it with our actual rule here, 2x minus 1. So we have 3 times 2x minus 1. What's that give us? Gives us 6x minus 3. So g of x is equal to 6x minus 3. That means if I were to graph that equation, I'd end up with this line right up here. So if we're showing it on our paper where we had our y-intercept at -1, and we rose 2 and ran 1, rose 2 and ran 1. Okay. We drew our line in there. This coordinate was at 2, 3. That's the one we focused on, but it happens to all of them. And we take and we plot our new line. We go to -3. That's our y-intercept, our b term. What's our slope? It's 6. Okay, so we rise 1, 2, 3, 4, 5, 6. We run 1. It's there. We rise 1, 2, 3, 4, 5, 6. We run 1, and that's there. Well, that 6 that we just ran up there, and we draw this line in, that point that was at 2, 3 is now at 2, 9. Okay, so this point stretched vertically by a factor of 3. Okay, this point actually stretched vertically by a factor of 3 as well, right? This coordinate right here was at 0, -1. So how far away from the x-axis is it? Close. Can't have a negative distance, but it's 1 away. That point is now right here. How far away from the x-axis is it? It's 3. So a point that was 1 away is now 3 away. We multiplied it by 3. So every single point, this point right here, is 3 away. Okay, 1, 2, 3. It is now, or it was, 1 away. Okay, the point that was 1 away is now 3 away. Okay, how many think you got it? Okay, we're stretching this way. All right, that's multiplying by the output. All right, well, let's talk about multiplying by the input. If multiplying by the output stretches vertically, what's multiplying by the input going to do? Stretch horizontally. Okay, so the next piece, multiplying by the input, Notice now we have g of x equals f of a of x. It's inside, right? Input inside. So we're taking g of x. It's going to be equal to f of a of x. The a is on the inside now. It's happening to the input. Once again, we're going to go with that same function again. The same boring f of x equals 2x minus 1. All right? So if I take f of x equals 2x minus 1, I'm going to make a 2. And we go through the math. That means rather than having x in here, we're going to have 2x. Yeah. And so we're going to stretch that. So once again, if I'm taking a look at my original function, f of x equals 2x minus 1, and we go through the same process and we say, okay, let's use our old friendly point 2, 3. We do f of 2. We know f of 2 is going to kick out 3 because we've done that a few times now. So f of 2 is equal to 3. We get the ordered pair 2, 3. And we do the math behind it. And then we graph it out. Okay, we have our y-intercept here at -1. We rise 2, we run 1, we rise 2, we run 1. Get that point, there's that 2, 3. Okay, so we have a couple points that we can track here. They're going to do g of x equals f of, we're going to say a is 2, so f of 2x. Which means we're going to do a horizontal stretch by a factor of 2. Remember, up here we did a vertical stretch. So this was a vertical stretch. By a factor of 3 up here. Okay. So don't let that arrow confuse you. That means I was just going to that graph. Vertically, you're actually stretching this way, up and down, right? Okay. Vertical stretch by a factor of 3. Okay. Well, this one's going to be a horizontal stretch by a factor of 2. Okay, so if I do the math, g of x is equal to f of 2x. This 2x gets plugged in for what over here? Anytime you see it in parentheses, it means it goes in for x. That replaces that. So the things that don't change, this 2 doesn't change. This minus 1 doesn't change. Just the parentheses. Notice that it's in the parentheses, so the parentheses. We're going to put parentheses around our variable. In fact, I've had some students have a lot of success just automatically whenever they write their original function. Anytime they see a variable, they just put parentheses around it. That way they have a visual clue. They're like, okay, I put parentheses around this when I write my function out. That way I automatically know that if something's in parentheses, if it's it's in the parentheses, that I have to put it in for the parentheses. Versus up here, was the 3 in the parentheses? Nope, so it goes on the outside of this. So 3 times 2x minus 1. Okay, so it might be a way for you to remember that if you just automatically put parentheses around your variable to remember. Okay, so this 2x goes right here. So what's that give me right here? Yeah, it gives me 4x minus 1. So did the 2x affect the 1? Not at all. The 1 is an output feature. But anyway, we go here. We're going to graph it up. So what's my y-intercept in this? -1. That point. Okay. Did that point move? Did the y-intercept move from here to here? It was at 0, -1, and now it's still at 0, -1. All right, well, let's check. We rise 4. 1, 2, 3, 4. We run 1. 1. That point is now right there. Okay, well, that coordinate is 1. No, 1 what? Not 4. 1, 3. Okay, and then we rise 4. 1, 2, 3, 4. We run 1. That point is at? Yeah, that point is at 2, 7. Okay, so let's kind of check these things out. This is where we were yesterday. Remember, we had a bit of confusion. At least that's what I got after class. So I want to make sure that we're good on this. This point right here, 1, 3, are we affecting, when we're doing inside, we're affecting the input, right? Which is the input, the X or the Y? The X is. So when I'm tracking this, if the input is changing, the output is staying the same. Right? Okay, so when I'm trying to find this point right here, or this point right here, these both have outputs of 1. This one has an output of 3. What would the next output be? If I rose 2 and I ran 1. My input would then be 3. My output would be 5. We good there? Okay. And so I could keep going through that process and come up with more points. But what I'm trying to do is I'm trying to track these outputs. So if let me do a couple more here. So if I rise 2 more and run 1, what do I get? 4 and 7. Everyone agree? Okay. And then let's go ahead and rise 2 more and run 1. What do I get? 5 and 9. And then rise 2 more and we'll do, oops, sorry, rose from the wrong spot. Last one is 6, 11. We good? Okay. So we've kind of built we've almost built a table right there, right? Okay, so we're affecting our input. So when I cut my input, notice this output shouldn't change. This output of 3, when do I get an output of 3 over here? What's my input when my output's 3? 1. Okay, notice it's 1. All right, well, let's keep going here just for a few, okay? 1, 2, 3, 4, 1. What's that? 3 what? 11. Okay, 3, 11. When did I have an output of 11 originally? At 6. Right? So here's 11, here's 11. What's happened to both? We had 2, 3 here. Now we have 1, 3. We had 6, 11 here. Now we have 3, 11. What's happened to both of those? What's that? Yeah, their output divided in half. Or excuse me, their input cut in half. The input that was 2 is now 1. The input that was 6 is now 3. What if my input was 8? What do you think it's going to be over here? 4. It cuts in half. Okay, well, how does that work since we have this is 2? Okay, remember yesterday I talked about everything being backwards in the parentheses? Right? When we added, we actually went backwards. You guys recall that? So we look back to our notes yesterday when we added to the output. Okay, rather than shifting to the right, we shifted to the left when we added. Okay, so we went backwards. When we're multiplying something by our output or our input, it's almost like it's dividing it. It's cutting it in half. And really what you're measuring here is you're saying, okay, if I'm going from, if I have an input of 2, I'm now going to have an input of 1. You're measuring your distance away from this axis. So how far is this point from here? like what's this length? A different color here. What's this length right here? Some of you are saying it, you just not. It has a length of what? Everyone on your fingers, what's the length? Come on, man. Yeah, 2. That length is 2. Well, now what is it? It's 1. It's cut it in half. This length right here is 6. Well, now what is it? 3. What you have is what's called a shrink. Okay? This was a stretch. It stretched it. This is a shrink. It's shrinking it. Okay? It's also called a compression. Okay? This is a horizontal shrink. By a factor of, not of 2. By a factor of what? How do you get from 2 to 1? 6 to 3? 1/2. Okay, so in your notes, you've got to think, okay, hold on, it was multiplied by 2, but I did it by 1/2. Okay, it's the, how many of you remember what reciprocal means? Reciprocal is just doing what? You flip it, right? So if this, when I say A equals 2 here, well, 2, the reciprocal of that is, so that's 2 over 1. The reciprocal is 1 over 2. So you always take the reciprocal. Remember, everything's backwards in the parentheses. So that's a note that you have to make to yourself. You do everything backwards in parentheses. You follow the order of operations. When you're dealing with functions like this, you follow the order of operations backwards. You're going to, when you see it being multiplied by 2, it's actually dividing by 2, or multiplying by the reciprocal is what we usually say. When you see addition, you actually are moving to the left on the number line versus to the right, which is the way you usually move. Okay? That's the one thing you have to remember on these. Okay, so horizontal shrink by a factor of 1/2. You are shrinking toward which axis? Which axis did we move towards, the X or Y? Towards the Y. Okay? Whereas up here, when we did a vertical stretch, this length was 3. This length is? That one's 9. You're stretching away from the x-axis. So when you're going vertical, you're moving away from x or towards x. When you're going horizontal, you're moving away from y or towards y. Okay? So just make a note to yourself that when you're going horizontal, it's going towards or away from y. When you're going vertical, it's going towards or away from x. All right. That is a lot of math. Dude. Everyone rate yourselves 1 to 5 right now. Let's see if we can do some of these together. All right. Take a look at this page. First part is going to be just doing some function stuff. All right? Let's try it. Let's give it a go here. We're just going to, I just want to touch on these first 3 problems right now, and we'll do a little more later, but for now, just these first 3 problems. All right, so notice up here it says, use the given function to describe the listed transformations and write the equation of the transformed function. F of x equals 3x minus 2. G of x equals negative 2x plus 4, and h of x equals 5. How do I know which of these functions to use? Tell your neighbor. You're going to have to put some thought into it. I haven't told you what to do there, so you've got to look at it. Okay, volunteer. How do I know which one to use? Solomon, what do you think? Yeah, by the f, g, and h. So for this one, do I use f of x, g of x, or h of x? I use the f of x because it says f. Yeah, there's an x, but it has f here. When would give me a problem number that I'd use this function for? Lou? 26, yeah, that's a g of x one. So this one says g. You got to use g. Give me a problem number where you'd use this one for. Kristen? Yeah, 30. Okay. 29, yeah, those work. Okay, we're going to be just using f for these first three. So let's go ahead and do this. What I want you to do is find out what f of 2x is, please. Figure out what f of 2x is. I'll pause there and let you work together. Hey, here we go. I appreciate, you guys, I really appreciate if you're, hey, when I say try them, I really mean try them. It doesn't mean you can't, it's okay to be a little confused, but you really have to try the problem, put out the effort. That way, right now when I'm going through it, you'll be able to identify your mistakes. If you're just watching me do another problem and not looking at your work, then you're doing what you just did for the last part of the lesson. So this is trying to take that extra step. So if you're sitting there looking at number 19 right now, for those of you that didn't try this, if that's you, then you're missing out on a piece of your learning here. Yeah. Question? Now let me show it. That way we can go through it, and then you can evaluate your work. So this right here, first question you need to ask yourself: inside or outside? It is inside. Okay? Remember, inside affects the x. All right? So remember what I said? A good way to remember this is to just, wherever you see a variable, put a parenthesis around it. Okay? Do we see a variable in this one? Of the h of x? Oh, right there, but remember, this is like a label. This is like its name, h of x. This has no mathematical bearing right now. So you're really looking at the rule. The rule is 5. Is there a variable with the rule? No. Is there a variable here with the rule? Yeah, so put a parenthesis around it. Is there a variable here with the rule? Yeah, parenthesis. Okay? So now when I'm looking at this, when it's happening on the inside, notice it's inside parentheses. That means when I take my original f of x equals 3 times x minus 2, what's in parentheses goes in parentheses. So I get 3 times 2x minus 2, which is 6x minus 2. That is f of 2x. Remember, the f of 2x is its name. Okay, this rule has the name f of 2x. This rule, f of x, has this name, 3x minus 2. Okay, two different functions so they have two different names. How many got it right? How many understand it a little better? Okay. Yeah. No, remember, this is a name. There's no math going on here. Guys, that is one of the hardest things for some of you to get. This is a name. You do not do any math right there. Its name is f of 2x. I know that's a weird name, and most of you wouldn't name your dog or cat that, but that's its name. All right? Be kind of a cool name. Come here, f of 2x. Then you can name your other dog f of 3x, and then your cat f of x. It's a little confusing.
We should get a classroom chick and name it f of 2x. This is like a little chick.
It could be. I agree.
Around.
Yes, Sam.
Yeah, f of 2x.
Yep. It's only affecting the input. Yep. So, you guys, when I'm looking at 20, 21, and 22, those are all my F problems, right? When I'm looking at those three, and I know I said only this top three, but let's go ahead and include that last one. Okay, when I'm looking at these three, which other of these three is going to only affect the parentheses? Tell your neighbor which of these three will affect it like this, and why is that? Okay, so we're going to go a 0 with a hand raise is 20, a 1 with a 21, and a 2 with 22. Everyone on your fingers, which one is it? It is 20. It's not 23, Luke. We only have 22. Can't go 3. Okay, it is number 2. You guys, why is it 2? Because of the parentheses, right? It's on the inside of the parentheses. So that's the recognition we're looking for. I want you to write out what f of, so we have f of x equals 3x minus 2. I want everyone to write out what f of x plus 2 is. Okay, show your neighbor what you got.
Does it have laser pointer on it though? Just add a laser pointer into this tip. Best part ever.
Okay, let's see. We've got 3. Notice this piece plugs in right there. The parentheses go to the parentheses. X plus 2 minus 2. How many made it at least that far? Very good. So parentheses go to parentheses, right? And then we distribute. 3x plus 6 all minus 2, which is 3x plus 4. So f of x plus 2 is 3x plus 4. Remember, the x plus 2 is that's its name. Okay, so we don't do any math on this side. That's just its name. Not if it's in f of x form. Nope, you won't. Okay, so this is what we've got. F of x plus 2 equals 3x plus 4. How many got it right? It's better than last time. Okay, do 20 and 21. If you have questions as I'm walking around, make sure you're asking them. Guys, let me start by saying this, the function stuff, this is not easy. I think this is difficult. Okay, but you really do have to persevere on it and keep working through it. You can't just stop and go, that's too hard, because the only reason I'm teaching it this year is because it does not stop coming up. It'll come up all year long, and then next year in geometry you'll kind of miss out on a bit because we don't use function notation as much. And then you go to Algebra 2. It is like the very first lesson you do. Chapter 1 in Algebra 2, your junior year, you do this. Like Chapter 1 and 2, you bring this. How many have friends in advanced algebra, Algebra 2? Just show them this packet, and they will know it. They spent the first two weeks covering this stuff, not on this packet, but they've done this exact packet. They should be, if you have a friend in Algebra 2 and you don't get this, you should be able to ask them, and they should be able to tell you immediately how to do it. Because we've spent the entire year on it so far. Okay, I mean, I'm not joking on it. It's so important for you guys to pick this up because it just doesn't go away. Okay, and I really appreciate you guys asking questions and persevering through it. That's why I'm taking so much time in class doing it. Okay, so this right here, as I'm talking through it, you guys, we need to recognize that f of x, this is a name. This is its weird name, f of x. The name that we're used to is 3x minus 2. You see this and you feel warm and fuzzy inside because you've dealt with 3x minus 2. You see this and you're like, that's scary, I don't get it. Okay? They're two different names. Like I said before, my brother Steve, now my brother actually has a business, and if you ever work for him and you call him this nickname, you won't work for him long. He'll probably fire you. Okay? His name's Steve. My grandma, back when he was a little guy, called him Bug. Stevie Bug. Okay? Stevie Bug. So the normal name was Steve. The weird name is Bug. Okay? Now, f of x Its normal name is 3x minus 2. Its weird name is f of x. Now, when I'm looking at this, this is saying you want 2 of f of x's. Well, this looks weird. You're like, well, that's weird. So let's replace it with its normal name. 2 of 3x minus 2. That's what I want. That's what 2 of f of x is. That's what that means. Remember, this is its weird name. This is the normal name. Okay? Now we multiply it out. That's 6x minus 4. So 2 f of x is equal to 6x minus 4. That's just the name. Yes? What I did is I took f of x is 3x minus 2. I plugged that in for f of x right here. That piece just jumped right in there. Replace that. Yep. And so the same thing happens on 21. F of x. Hey, pay attention, guys. F of x is right here. That's its weird name. What's the normal name? 3x minus 2. So we put that in. 3x minus 2 replaces f of x. That goes in for that. So this plugs in for the f of x. Notice x is still x. The parentheses didn't change. So we keep them the same. Okay? And then we have that minus 2 on the outside. So if I'm looking at this one, this says f of x minus 2 is equal to 3x minus 2 minus 2. Now remember, do we need to do any math on this side? No, that's just its name. This is equal to 3x minus 4. So f of x minus 2 is equal to 3x minus 4. Remember, this is a name. We don't care about that.
So the regular name, 3x minus 2, like you're just plugging that in. Like so for 20, you just plug that in just for that.
Yep.
That's what I think.
Hey guys, hold on one second before you clean up. Your assignment is to finish this page tonight. The best you can. Okay?